Look at this question. The question is x to the power 6 minus x cube is equals to 2. First of all, we can just write this x cube as x cube whole square minus x cube is equals to 0 is equals to 2. Now let's assume that y is equals to x cube. Now substituting our assumption, so we can write this as y square minus y is equals to 2. Further, just move this 2 on the left hand side, so its sign gets changed. Now this is a quadratic equation, that is y square minus y minus 2 is equal to 0. We can find the factors of this equation by breaking up the middle term. Here when you're going to multiply this quadratic term with this constant, you get the product minus 2y square, right? So in order to break up in such a way that we get the middle term minus y, you can break up it as minus 2y plus y, right? Now you can write this as y square minus 2y plus y minus 2 is equals to 0. Out of these two terms, taking out y common, so you have y minus 2. Taking out 1 common, here you have y minus 2 inside the bracket. Now in these two terms, taking out y minus 2 common, here you are left with y and plus 1 is equals to 0. Now we have two possibilities, that is y minus 2 is equals to 0 and y plus 1 is equals to 0. Further you can write it as y is equals to 2 and here you have y is equals to minus 1. Since y is equals to x cube, as we so substituting this here, we get x cube is equals to 2, right? Now taking cube root on both sides, so this 3 gets cancelled, so we have x is equals to cube root of 2. Now this is one solution of x. Now here you can see, if we substitute this assumption here, that is x cube is equals to minus 1. Further you can write this as x cube plus 1 is equals to 0. Now for solving this equation, we have to apply the formula here, that is x plus 1 into x square minus x plus 1 is equals to 0. Now this implies, working on this, that is x plus 1 is equals to 0 and x square minus x plus 1 is equals to 0. So we get here x is equals to minus 1. Now this is the second solution of x. Now this is a quadratic equation. We have to compare this equation with the standard quadratic equation, that is ax square plus bx plus c is equals to 0. So we have a is 1, b is minus 1 and c is 1. Now putting the values in the quadratic formula, that is x is equals to minus b plus minus under root b square minus 4ac upon 2a. So we have b square has a value minus 1 minus 4, 1 into, this is 1 upon 2 into 1. So x is equals to 1 plus minus, this is 1 minus 4 upon 2. Further, you can write this as x is equals to 1 plus minus under root minus 3 upon 2, or x is equals to 1 plus minus q under root 3 I upon 2. So this is the third and the fourth solution of x. Now these are the complex roots of x. Now we are going to verify the real roots. So for verification, first of all, let's check for x is equals to cube root of 3. So we have x to the power 6 minus x cube is equals to 2. Putting the value here, that is in all to the power 6 is equals to 2. So here you get the power 1 upon 3 whole to the power 6 minus 2 to the power 1 upon 3 whole to the power 3. Now this 3, this 6 gets cancelled. This is 2 square. This 3 gets cancelled. This is 2 is equals to 2. This is 4 minus 2 is equals to 2, or you can say 2 is equals to 2. Now this implies that x is equals to cube root of 2 is one of the solution of this equation. Now let's check for x is equals to minus 1. Now put this equation minus 1 plus, sorry, this is minus, right? Since this is a even power, so the negative sign gets changed into positive. This is plus 1 minus, this is an odd power, so the sign remains negative. Now this is 1 plus 1 is equals to 2, or you can say 2 is equals to 2. Now we can write the solutions of x as x is equals to cube root of 2, and the second solution is minus 1. Third is 1 plus under root 3i upon 2, and the fourth is 1 minus under root 3i upon 2. I hope you understand the question, and if you like it, kindly subscribe my channel. Thanks for watching.